All right, welcome everybody. Today we're talking about digitalization, digital twins in machine tool, as we're approaching Machine Tool Day, as well as EMO Milan. We invited a guest from Siemens Corporation, Uwe Ruttkamp. He's the head of business segment machine tools at Siemens Machine Control Unit within the digital industries. Welcome, Uwe. Why don't you introduce yourself, give us a little background how you got started in the motion control first up.
Yes, thank you very much for having me, Lucien. I started with Siemens in 1994 and have gone through a couple of assignments from R&D, software development, all the way through product management. And then I had the chance to run, actually, then I had a chance to run a factory that made gears. So I didn't know at that time what that would be helpful for. We had 100 CNC machines then. And then later throughout my career, I got head of the machine tool systems business and having the Xenomeric as a key product for CNC control. So, and then of course I had a lot of advantages from having the assignments before. And that's where I am today.
Many thanks. Very impressive career. And I started a career about the same time as we were talking earlier. Launched my career on a CNC tool shop, and maybe it would be interesting to see, since I moved into more of industrial software, maybe just to get the audience up to speed as to what are some of the trends in the machine tool that you perceive and some of the current challenges and potential opportunities within the space.
Yeah, one clear trend in the machine tool industry is, of course, digitalization. Absolutely. You cannot live with machine tools without talking about the digitalization nowadays. And there is digitalization going on across the board. It's from the job preparation to the actual operation on the machine tool usage side, but as well, of course, in the development of machine tools, you can use digital twins to speed up development time. So there is a lot of things around digitalization that is really making machine tools better.
Very good. Thanks for an insight. And of course, it's been over 3 decades that, of course, in the CNC, you used to take a drawing and process it and spits out G codes and M codes, and that would run for X amount of time to produce parts. Now, let's switch a little bit of focus on digitalization on how can that help reduce, let's say, cost, time, and energy, perhaps in an application context, like replacing gear wheels that you referenced earlier on your career.
Yeah, our highlight showcase on EMO in Milano, beginning of October, actually is about gear wheels. And what we are doing there is we are showing that if a broken gear wheel is to be replaced, it is much easier and also requires less energy consumption to do it in an additive manufacturing way. So we are flattening the gear, build it back up with direct energy deposition mechanisms of additive manufacturing, and then do the final finishing of the gear wheel and save 60% of energy by doing that compared to building a complete new wheel from the start. So this is what we show at EMO. And this combines very nicely additive manufacturing and classical CNC technology. And it also shows, you are asking about digitalization from an end user perspective. It also shows how you can use digitalization to actually get there, because there is a lot of software involved to identify the broken parts. There is software involved to draw the pieces or the work pieces. And of course, the entire manufacturing later on is benefiting a lot from
that. Great insights there. And maybe I want to, before we get to the digital twins, I wanted to kind of expand a little bit just on what you've mentioned around the additive manufacturing. So it's in our nature to try to solve problem using what has worked before. Do you think the traditional machine tool builder is ready for the new ideas, such as the additive manufacturing, the 3D printing, and what are the most significant challenges to adopt such as technology?
Mm-hmm. Yeah, well, there are multitude of OEMs that are into additive manufacturing. There are the traditional CNC machine builders that start also additive manufacturing as an extension of their product line, and they are mainly in the area of metal. So direct energy deposition, for example, as a process to build the part. And there are others which were not in the CNC business before and start new in the machine building part just with additive. And very often those are more on the plastic side of things. So building work pieces based on plastics, and the a lot of customers from that end come from universities or spin-offs of universities, or have an idea about how they move forward, but then at some point in time throughout their experience, a couple of them find out that at the end, when you want to sell a machine and not just use it for experimental purposes, for example, when you want to sell a machine, you are into a lot of things that are the same as for traditional machines. Because you have a cabinet, you need to comply to certain rules, UL in the US, CE in Europe, you have delivery tax issues, you have a couple of things that you need to be aware of as a machine builder, regardless what technology you are using in the machine. So, and then things come together, and a couple of them, and hopefully more and more, will find out that going with a traditional vendor like us, like Siemens, that is supplying to machine tool builders for a long time, are also good partners for additive manufacturing. And as we approach now EMO, we are of course showing our new control, Sinomeric One, which we have launched 2 years ago on EMO 2019, and now again show it with new features. We have a lot of customers that use Sinomeric One as their choice of control for additive manufacturing machines.
Very interesting. So maybe expand a little bit. What does that new controller do for additive? What is the main purpose for that?
Yeah, the main purpose is that besides the fact that it's just faster and better than the controller before, the 840 DSL, very well known controller, Sinomeric One is an updated version of it. The most important thing about Sinomeric One is we call it the Digital Native CNC. We call it the Digital Native CNC because all the digitalization that goes into a machine tool is already part of the product portfolio. Like, for example, create my virtual machine or run my virtual machine. These are two software packages that are not to be distinct from the Sinomeric One because it's part of the entire portfolio. And therefore, create my virtual machine, or with create my virtual machine, a machine builder can build the machine and simulate the machine completely on his laptop. It's basically a CNC controller on your laptop. That's basically what it is. And of course,
so it extends the possibility through digitalization and digital twins, especially when it comes to virtual development and commissioning of that machine. And you've touched on simulation, and perhaps this would be a good segue into the digital twin aspect of that. And you've referenced some energy cost savings, and maybe expand on the role that digital twins in the production process for machine users might be. Particularly, how far are we from adopting that digital twins in a CNC factory, like you referenced at the beginning of your career, 150 CNC machine?
Yeah, from a machine user's perspective, the digital twin is an important element for training, for example, for training the workers. And I've talked to customers that said, well, when we buy a new machine, and we are talking about a machine user here, when we buy a new machine, we start training our workers to use the new machine once the machine is on the shop floor. But not anymore, because with the product Run My Virtual Machine, with a digital twin of the machine tool, you can start before the machine is delivered. So the workers are already trained, know how to operate. You can run in the first parts in a virtual fashion. You know how long a part will produce because it produces it in real time. So you can measure how long it will take to build that part and get the entire integration in your factory pretty much set up way before the machine is delivered. And once the machine is on the shop floor, you can reduce your time to bring the machine to being productive a lot.
Got it. Can you expand a little bit on what sort of investment, if it's at a fraction of the total cost of the machine tool, to add that capability of a digital twin and a simulation for training and stuff like that?
Yeah, I cannot give you a number because every machine tool has a different cost position, and if it's a 3-axis machine or a 5-axis machine, different cost is involved. But it certainly pays off. I mean, going to a digital world always pays off because once you, as a machine user, as a factory manager, have decided to buy a new machine, it's like you decided to buy a new car, or it's once you decided to get a new computer. You want to have it right away. You don't want to wait. Yeah. Once you made the decision, you want to have it. And with a digital twin, you can have it on the spot. And if and so it pays off right there. And from a machine builder's perspective, he can talk to the machine user and show him options, variations of the machine in a digital fashion, and can get the complete sales process on a complete new level.
Got it. Now, let's switch a little bit of focus on the ease of integration, and perhaps we focus on one aspect, which is the robots, which seems to be important to a customer, as you show in the highlight the case during the EMO show. Do you see a growing trend in the machine tool industry to do robot programming from the CNC? And particularly the CNC's programming, it's been, gosh, almost Fortran based. It's very archaic.
Yeah, I mean, the integration of robots into a complete cell is actually state of the art. Because once you go into digitalization and automation, there is a robot involved, that's for sure, for either loading the machine or the raw material into the machine, or taking the finished part out of the machine. This all can be automated and doesn't have to be done by a human person. But there are 3 advantages that come with having this integrated into the CNC controller. First of all, you don't need an additional controller to run the robot. That's the first advantage. So it's simply a cost advantage, very simple. The second advantage is when the worker is already capable of operating the CNC machine, he is immediately able to operate the robot as well, because it has the same user interface. We are integrating the programming not as a separate programming tool to program the robot. It's part of the Zinumeric, and you basically can just interleave even the G-code program and the movement of the robot within one program. And then of course there is a third advantage, and the third advantage is that when something does not work well, if something goes wrong, whatever happens, there are a couple of things that can happen. The service personnel on site knows exactly how to get a CNC machine back up to speed, get it back to work, and he can apply the same knowledge to the part of the robot as well. So there are 3 big advantages for integrating the robot into the CNC controller, and then you have a very nicely automated machine with automatic loading and unloading.
Great insights, and it sounds like an exciting time ahead in the machine tool shop. So look forward to see the development there. And now I know you're presenting during the Siemens Machine Tool Day as well as part of the EMO Milano on October 5th. Why should people attend? What is yet to come from Siemens there?
Yeah, why should you attend? Because I'm talking with a few customers. I'm talking with customers about trends in the machine tool industry, what their experience is, talking about their experience with starting with Numeric 1 and what advantages it had for them as a machine tool builder in the process of engineering or in the experience to actually use it as a sales tool to sell it to their end customers. It's going to be an exciting talk.
Looking forward to it. And if you're in the audience, stay tuned and engage in a dialogue with our guests from Siemens or others, leveraging the hashtag you see on the screen, and we'll make sure we get the questions addressed. Uwe, thank you so much for your time.